eCyberForce mission is to provide small and mid-sized businesses the network, online service, and cybersecurity monitoring solution in the industry. In recent years, there has been a high surge in cyber attack on the internet, leaving the small and mid-sized businesses very vulnerable. For example, 57 times surge in the ransomware attack in recent years, setting the cost for the economy in cyber criminal over $10 trillion in loss by 2025 in the investment. Thus, there's a dire need for a comprehensive cybersecurity solution. Some of the cyber attacks are malware, phishing, especially ransomware, attack, man in the middle, DDoS attack. Introducing eCyberForce MacroProbe software as a service to provide small and mid-sized businesses proactive monitoring solution for their network, online service, and cybersecurity. The MacroProbe provides a powerful platform for data collection, providing metadata collection, as well as raw packet data collection and event logs. It also provides the powerful platform for application development. Application that has cutting-edge technology features such as machine learning, anomaly detection of your operation, deep learning forecasting of your infrastructures, big data troubleshooting to find the root cause of the problem, and cyberattack AI to answer any question that concern your domain, as well as any legacy traditional monitoring features. Some of the features are like the big DDoS monitor, the big government monitor for blacklisting, the big cyber attack to detect cyber malware, ransomware, the big application response time monitor, the big link monitor, and the DDoS anomaly detection, and the link capacity planning forecast, and the cyber intel AI to answer any question that concerns your domain. The applications range from real-time to advanced cybersecurity to machine learning to deep learning to online service and user experience. The MacroProbe can be used by small and mid-sized businesses to deploy across multiple sectors such as communication, online services, manufacturing, financial services, public sector, retail, and education. The basic architecture of the MacroProbe is that it has the Ethernet network interface and the data collector that collect metadata and log data into the Postgres database, which are consumed by the application platform, and it has a web server that connects the client to the MacroProbe on the internet. Let's deep dive into the MacroProbe demo of its network, online service, and cybersecurity monitoring. So we launch a client onto the MacroProbe, use port 9999, which is reserved for the MacroProbe accessing the MacroProbe itself. We authenticate, and here we have the home page of the MacroProbe. Let's look at the big data monitoring. Let's look at the interface 10 training 184 for the last 24 hours. Look at the link bandwidth for the last 24 hours. In this big data monitoring, we monitor the global interaction to pinpoint the root cause of a problem. Let's say we navigate along the overtime chart right here in link usage over time. Let's pick a point of interest where there's a spike or anomaly. Let's say this point right here. And when we click on it, it shows the interaction of the link to that point within the hour. And you can see that it shows the interface discard, buffer discard, packet size distribution, and packet rate over time, and link utilization over time on that point of interest. Let's look at the big application monitor for bandwidth of the application. At this point in time, we navigate along the link usage over time for the global interaction of the app in the bandwidth usage. Let's look at this point right here where there's a spike. We click on it and we have a global interaction of the app summary, the server summary, and the client summary, along with its app server and of the particular app up here. If we're interested in, let's say, HTTP app right here, let's say we look at the app with the highest utilization right here. It shows the server summary and the client summary. It does have a client summary, and let's look at DNS. DNS, we have the server summary without a true DNS server and the client summary without a true client connected to this particular DNS server, 10.192.168.39.24. And above here are the summary and the overtime of the DNS application. If we look at this at the server, we have the summary of the particular DNS server. Let's look at the application response time over time. Over here, we look at the global interaction of the data, and we navigate at the point of navigation is down below here on the location response time over time. Let's pick a point of interest to navigate to this point where there's a spike or anomaly. We click on it and we see the global interaction of that data point within the hour. And we see the application summary, DNS server summary, and client summary. Let's pick a point of interest. Pick HTTP to be an application where we want to focus on. And here we have the HTTP server summary of all the HTTP server and the client summary. Above here are the HTTP summary, the HTTP server summary, and the HTTP client summary. Let's look at the big DDoS monitor. Big DDoS monitor show the global interaction between the attacker, the server being attacked, the URL being attacked, and the application being used for the attack, and the infrastructure that are impacted by the attack, which are the DNS servers, the web service, the backend database service, and the application logistics. We navigate below here on the point where there's the most DDoS attack. Let's say at this point right here. And now we see the global interaction of the DDoS model. And let's pick a point where it has the worst error. This is the attacker that is attacking the infrastructures. We click on it and it shows the global interaction of the attacker with regard to the server that it's attacking and the URL is attacking and the application that it's being used to attack the service and the infrastructure that are impacted by that attacker. Let's look at the big cyber attack model. We look at the data for today, and let's look at the conflictor cyber attack. Up here we have reflection in the global interaction of the cyber attack, number of cyber attack over time on the conflictor, and below here we see the conflictor have the event summary, the port scan summary, and the server summary, and the client summary, and the flow summary. Let's look at the service model for today, and let's look at the URL that we're interested in. Let's look at the cnn.com URL. Up here reflect the response time of the URL of the service. And below here we have a reflection of the interaction of the application summary, the location summary, server summary, and the client summary and the flow summary of that particular URL. Let's look at the anomaly detection. We have anomaly detection on a link network, anomaly detection on application, anomaly on application server, anomaly on internet service, anomalies on online service, anomaly on user experience, anomaly on data center services, anomaly on DDoS attack, anomaly on blacklist violation, anomaly on botnet spreading, and remote login hacking. Let's look at the internet service anomaly detection for yesterday. The evidence of it on the weather. Now, if you look at the chart, look at the 5D chart. All the data clutter in this region are considered to be normal operation. Any data outside here are considered to be an outlier. That is the anomaly. This is the anomaly because it has a high, this point right here has high DNS response time. This anomaly right here has a high HTTP response time. This anomaly right here has a high DNS error. Let's look at forecasting. Forecasting. We want to forecast a link 10/20/184 using last 24 hours of data for the next 7 days. And again, looking at this data, we see that the data in the past are random and disorder, whereas the data in the future trend are converging to a bit rate of 1.2 megabit per second, utilization at 1.3%, with a packet rate of 447 packets per second. Let's look at the server capacity planning for the web server of a particular server. Look at this over again, is that we see that the past historical data is a little bit random, but the future trend for the server capacity is converging to a particular response time of 6,883 milliseconds, with the server bitrate of 28 kilobits per second and the link bitrate of 1.8 megabits per second. Let's look at cyberattack AI. Cyberattack AI, we have a basic structure of the query. Is that it has to have a command, which is show me or what is. It has to have a parameter, which is response time, bandwidth, bitrate, context, like say last 24 hours or top 5 server, something like that. So let's look at this for example. First, we want to see all the parameters. So we want to show all the table in the database. So it shows you all the table in the database, and you can download this table in CSV file for a complete listing of the tables. So let's say, for example, you want to find the average of TCP response time. You see, show me the average TCP response time for the last 24 hours. So you got the average TCP response time for the last 24 hours. You can ask, show me the top 5 was server in TCP response time for the last 24 hours. It will show you the top 5 servers that have the worst TCP response time. So let's say, for example, you want to see, show me all the cyber attack in the last 24 hours. will show you all the cyber attack within the last hour. So you can see, show me on the event log for the last hour. Oh. Show me on the event for the last 24 hours. It will show you all the event log for the last 24 hours. So let's say, for example, you can do show me on the botnet alarm for the last 24 hours. It will show you all the botnet alarm for the last 24 hours. So let's say you want to do show me on the blacklist DNS alarm for the last 24 hours. It will show you all the blacklist detect on DNS URL on the last 24 hours. So I want to show you the user experience, how to monitor your user experience. Okay. We use the application response time monitoring, client monitoring. For the last 24 hours on interface 10.20.184, client response time. We monitor this for the worst response time client. We do client response time over time. They will show the client response time in corresponding with its load. You can also sort this by 4xx, and at this client right here have the worst 4xx error, and it will show you the client response time corresponding to its transaction load for the last 24 hours. You can see that. So let's look at the data center services monitor, performance monitor. So for data performance monitor, we monitor on interface 10.20.100.84 for the last 24 hours, and we monitor the ATP server monitor. And at the worst response time server, this server right here, we look at the response time over time, and we'll show you the server response time with corresponding to its load. Now we can go back and sort it by worst 4xx error, and this is a server that had a 4xx error, worst 4xx error, and we monitor over time its response time with respect to its transaction load. And you can see the data. You can draw a line right here. You can tell whether it violates any responsiveness or not. Let's look at the alarm monitoring. We monitor alarm based on n-bit transition alarm. 1 bit is random, 50-50, n-bit. 5 bit go up to 96.875% certainty. Now we monitor, the higher the bit, the more reliable the alarm. We monitor the alarm based on availability, responsiveness, and protocol error. We monitor alarm on the link bandwidth, on the TCP app, on the TCP server, DNS server, HTTP server, SFTP server, IMAP server, POP3 server, FTP control server, and FTP data server. Let's look at the interface alarm. Here we have an alarm happened at 5:10 p.m. today. 87% certain that this interface, 192.168.1.175 link is out of service where the utilization is below 0.01% for at least 3 consecutive occurrences. Let's look at the HTTPS server alarm details. Alarm details. We have 86.87% certain that HTTP server application has been unavailable at least exceeding 400 milliseconds for at least 5 consecutive occurrences. Okay, that concludes our demo. Thank you.